Hello everyone, this is Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equations with variable equations. So let's get going. Problem. Solve x squared d squared minus 2xd minus 4 into y equals to 32 of log x whole square. Given differential equation, x squared d squared minus 2xd minus 4 into y equals to 32 into log x whole square. We are given directly a Cauchy's equation, right? Which is a Cauchy's equation. Now, let's change the given equation with variable coefficients to an equation with constant coefficients by making a substitution. Put x equals to e power z, then log x equals to z for x greater than 0. Let theta equals to d by dz. Here theta is a differential operator with independent variable z. And x d equals to theta, x square d square equals to theta of theta minus 1. Then the above equation becomes theta of theta minus 1 minus 2 theta minus 4 into y equals to 32 into replace log x by z will get z square, 32 z square. Then theta into theta, theta square minus theta minus 2 theta minus 4 into y equals to 32 z square. Then this becomes theta square minus 3 theta minus 4 into y equals to 32 z square, which is in operator form, right? F of theta into y equals to some function in z, right? Which is in operator form, where f of theta equals to theta square minus 3 theta minus 4. We need to find the general solution of the given equation, which is given by yc plus yp. Let's now find yc and yp. The auxiliary equation is f of m equals to 0, where f of m equals to, we have f of theta, theta square minus 3 theta minus 4, right? And then f of m will be, just replace theta differential operator by m, so that we'll get f of m equals to m square minus 3m minus 4. Then our auxiliary equation becomes m square minus 3m minus 4 equals to 0. Now let's find the roots. Write minus 3m as minus 4m plus m. Minus 4m plus 1m is minus 3m, right? Minus 4 equals to 0. Now take m common from these two terms, we'll get m times m minus 4, and write the next two terms as it is. If you notice, we are having m minus 4 in both the terms, so let's take m minus 4 common, we'll get m minus 4 into m plus 1 equals to 0, right? Now equate each factor to 0. From m minus 4 equals to 0, we'll get m equals to 4. And from m plus 1 equals to 0, we'll get m equals to minus 1. Then we'll get m equals to 4 minus 1, or m equals to minus 1 and 4 are the real and distinct roots of our auxiliary equation. The roots are real and distinct, or we can say real and different. Okay, we can replace e power z by x and z by log x to the base e. But here we are having e power minus z and e power 4z. So how we can replace it by x? Let's just write e power minus z as e power z power minus 1 plus c2 into e power z power 4. Now it's easy to replace e power z by x. Then yc becomes c1 x inverse plus c2 x power 4. We know that x power minus n is 1 by x power n. Then we can write x power minus 1 as 1 by x. Okay, which is equals to c1 into 1 by x is c1 by x plus c2 x power 4. Then yc will be c1 by x plus c2 x power 4. We got yc. Let's now find yp, particular integral. We can find particular integral using yp equals to 1 by f of theta into RHS part. Then yp becomes, we have f of theta, theta square minus 3 theta minus 4, and RHS is 32z square. We can write it as 32 into 1 by f of theta into z square. See, this is of 1 by f of theta into z power k form. Okay. Now, the denominator we are having the terms which is in descending order, right? Let's take the lowest degree term common from all the three terms. So we need to take minus 4 common from all these three terms. But in the first two terms we don't have minus 4. So let's multiply and divide minus 4 to the first two terms. Then yp becomes 32 into 1 by multiply and divide minus 4 to the first two terms. Okay, and write this minus 4 as plus of minus 4. Then it will be easy in the next step to take minus 4 common from the two terms of denominator into z square. This is equals to 32 into 1 by, take minus 4 common from the two terms of denominator, we'll get minus 4 into theta square minus 3 theta by minus 4 plus 1 into z square. Right? This is equals to 32 into, split the fraction as 1 by minus 4 into 1 by theta square minus 3 theta by 4. We can write theta square minus 3 theta by minus 4 as minus of theta square minus 3 theta by 4 plus 1 into z square. So we can write it as 32 into, right, 1 by minus 4 as minus 1 by 4 into 1 by, we can write minus of the term plus 1 as 1 minus of theta square minus 3 theta by 4 into z square. 4 ones are 4 eights are. This is equals to minus 8 into, see, this is of 1 by 1 minus x form. So we can write it as 1 minus x whole inverse. Then we'll get 1 minus of theta square minus 3 theta by 4 whole inverse into z square. Now we can expand this term using 1 minus x whole inverse formula, binomial series expansion formula, 1 plus x square plus x cube plus so on. So before applying this formula to this, we'll find derivatives of z square. Theta of z square is 2z, theta square of z square is 2, theta cube of z cube is 0. Likewise, theta power 4 of z cube is 0 and theta power 5 of z cube is 0 and so on in general. Theta power k of z cube is 0 for k equals to 3, 4, 5 and so on. By keeping this in mind, we'll expand 1 minus theta square minus 3 theta by 4 whole inverse. Okay. If you want, I'll show you theta square of z and theta cube of z. I mean, this is z square, right? Sorry. It's z square. Theta square of z square is theta of z square. We have the value of theta of z square, which is 2z, right? Again, we can write this as 2 into theta of z. Theta of z is again 1. So you'll get 2. Right? Likewise, find theta cube of z square. Right? Theta cube as theta square of z square. We have the value of theta square of z square, which is 2. Find theta of 2, which is derivative of a constant with respect to z is 0. Okay. So theta cube of z square is 0. If theta cube of z square is 0, hereafter we'll get all the higher derivatives 0. Let's now expand 1 minus of theta square minus 3 theta by 4 whole inverse. Using this formula, we'll get 1 plus theta square minus 3 theta by 4 plus theta square minus 3 theta by 4 whole square plus so on, which is equals to 1 plus theta square minus 3 theta by 4 plus theta square minus 3 theta whole square by 4 plus so on. Okay. Coming to yp, we can write yp as minus 8 into expansion of 1 minus this term whole inverse is 1 plus theta square plus 3 theta, minus 3 theta by 4 plus theta square minus 3 theta by 4 whole square plus so on into z square. Now observe this expansion carefully. Leave yp. Just observe this expansion. This becomes 1 plus theta square minus 3 theta by 4 plus expand theta square minus 3 theta whole square. Theta square minus 3 theta whole square is theta square whole square plus 3 theta whole square minus 3, 2 3s are 6 theta square into theta. Right? This is equals to theta power 4 plus 3 theta square minus 6 theta power 2 plus 1, 3. So we have theta power 4, theta cube, which are higher derivatives. So we can neglect theta power 4 and theta cube later. Okay. So we'll get expansion of theta square minus 3 theta whole square is by 4 plus so on. Right? See, in this term or from this term, we are having two higher derivatives. Next we'll get, here we'll get theta square minus 3 theta whole cube by 4. Okay, this is 4 square, right? 4 cube. And here we'll definitely get terms involving higher derivatives, theta cube, theta power 4, theta power 5 and so on. So definitely we can neglect all the terms from here. Okay, so we can neglect all the terms from here. Likewise, we can neglect theta power 4 and theta cube from the third term. Okay, we'll see that. Since theta power k of z square is 0 for k equals to 3, 4, 5 and so on. So neglect higher derivatives theta cube, theta power 4, theta power 5 and so on. Okay, and we can write this equation as minus 8 into 1 plus theta square minus 3 theta by 4 plus theta square minus 3 theta whole square by 4 square plus theta square minus 3 theta whole cube by 4 cube plus so on into z square, right? This is equals to minus 8 into 1 plus theta square minus 3 theta by 4 plus expansion of theta square minus 3 theta whole square is theta power 4 plus 3 theta whole square is 9. 3 square is 9. Theta square minus 6 theta cube, right? Write the expansion of theta square minus 3 theta whole square here. You'll get theta power 4 plus 9 theta square minus 6 theta cube by 4 square is 16 plus so on into z square. Now let's neglect the higher derivative terms. So terms from here will definitely involve, all the terms from here will definitely involve theta cube, theta power 4, theta power 5 or so on. Okay, all will get higher derivative terms, I can say. And also we can neglect theta power 4 and theta cube from the third term. Okay. yp becomes minus 8 into 1 plus 1 by 4 into theta square minus 3 theta. I am going to neglect all the terms from here. Okay. Then I'll get plus 1 by 16 into 9 theta square into z square. Then yp becomes minus 8 into 1 plus 1 by 4 theta square minus 3 by 4 theta plus 9 by 16 theta square into z square, which is equals to minus 8 into 1 into z square plus 1 by 4 into theta square of z square minus 3 by 4 into theta of z square plus 9 by 16 into theta square of z square, which is equals to minus 8 into z square plus 1 by 4 into theta square of z square is 2 minus 3 by 4 into theta of z square is 2z plus 9 by 16 into theta square of z square is 2. Okay. 2 2s are 2 2s are 2 8s are. Then yp becomes minus 8 into z square plus 1 by 2 minus 3 by 2z plus 9 by 8, which is equals to minus 8 into z square minus 3 by 2z plus 9 by 8 plus 1 by 2. Simplify 9 by 8 plus 1 by 2. Take the LCM of 8 and 2. 8 is our LCM. So you'll get 2 2s are 4. Multiply 4 to this one. You'll get 4 plus 9 plus 4 by 8, which is 13 by 8. Then yp becomes minus 8 into z square minus 3 by 2 into z plus 13 by 8. See, here we are having yp in terms of z. So let's write it in terms of x. Replace z by log x to the base e. Then yp becomes minus 8 into, because we are having z equals to log x to the base e and e power z equals to x, right? We don't have terms involving e power z, but we have only z, so we need to replace z by log x to the base e, right? Then yp becomes minus 8 into log x to the base e whole square minus 3 by 2 into, replace z, We get log x to the base e plus 13 by 8. So these are required yp. We got yp and yc. Now let's write the general solution. The general solution is given by y equals to yc plus yp. Then y equals to yc, we have c1 by x plus c2 x power 4, and yp is minus 8 into log x whole square minus 3 by 2 log x plus 13 by 8. So this completes the problem. So we have seen a problem from higher order differential equations with, or higher order linear differential equations with variable coefficients in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.